Good afternoon, young friends. You are welcome to our course Manufacturing Processes 2, the module that is continuing general purpose machine tools, and today's lecture topic is use of various attachments used in machine tools. Now, what are the objectives today? This lesson will enable the students comprehend and state the use of accessories and attachments in machine tools. Second, realize and identify why and when attachments should be used or necessarily used. And third, describe construction and application principles of the various attachments used in center lathes, drilling machines, shaping machines, planing machines and milling machines, which are most conventional general purpose non automatic machine tools. Now, let us have a quick glance into accessories and attachments. Accessories and attachments both are used in machine tools, but there are differences. What are the differences between accessories and attachments? In respect of use, accessories, remember, these are essentially used for regular work. Each machine tool is specified for a range of activities. This is called stipulated work, and for conducting the stipulated activities, some devices, extra devices are to be incorporated into the machine tool. But in the attachments, which are very occasionally used and beyond the stipulation range, you want to suppose a lathe has got some stipulation, you want to do something which cannot be or should not be done in lathe, but we shall do it in a lathe deliberately with the help of an attachment. This is very occasional. Examples of accessories which are inevitable for regular work: chucks, collets, steady and follower rests, different types of vices, clamps and other things in different machine tools. What about in case of attachments? Say copying in lathes, planing machines. Now, you are doing copying in lathe, milling machine, planing machine with the help of certain attachments as and when required. Thread milling, so you are doing milling in lathe, tapping in drilling machine. So, these are various attachments which are very occasionally used when almost compelled. Ordering. Now, accessories are ordered along with the basic machine tools. So, when you purchase the lathe, suppose you always enlist the accessories, say 4-jaw chuck, 3-jaw chuck, steady rest, follower rest, all these things should be enlisted along with the machine tool, but the attachment need not be attached to associated with the machine tool. It can be purchased or ordered any moment, you can do this, and it has to be done separately. Payment, when you will pay? The payment for the accessories are covered within the basic machine price. So, the total price covers the payment of the accessories, but in case of attachments, they have to be ordered separately, they have to be paid separately as and when required. What about the future? Accessories, there is a continuous need and use, and this will continue. Whenever machine tools, conventional machine tools or any machine tool be used, accessories are always have to be used, say for chuck, but the attachments, they are going to be obsolete, gradually obsolete. The reason is this unstipulated work or special work to be done in another machine tool. Why it is necessary? When it is necessary? When all types of machine tools are not available, only few 1 or 2, 3 machine tools, say shaping machine, a lathe and a drilling machine is available, but you want to do tapping, then you have to take help of a tapping attachment and a lathe. You have to do milling, say thread milling, long thread milling, you do not have such kind of machine, then you have to use a attachment into a lathe. And beside that, this very quick and vast advancement is taking place in the area of machine tool sophistication, versatility, automation, and especially flexible automation like say CNC, machining center. As and when these machines are coming up, the need and use of attachments are gradually decreasing. Now, why and when attachments should be used? These will be gradually eliminated or obsolete, but even now another few decades this will continue in some areas. What are those areas? When and why attachments should be are needed and to be used? Look, this should be used only on very ordinary conventional machine tools, say center lathe, ordinary column drilling machine, ordinary shaping machine, ordinary non-conventional general purpose non-automatic milling machine and so on. Limited facility exists. If you have enormous facility to conduct all types of machine tools to conduct any kind of work, then you need not go for any attachment. If tapping is required, do in a tapping machine. If you need a copying, you do in a copying machine and so on. Only when facilities do not exist, you have got only few machines, but you have to do different type of work, then you have to take help of attachments. Very small production requirement. Now, the production requirement, it is only for piece production or job order production, it is not for mass production or lot production. 1 or 2 pieces occasionally, maybe once in a month or once in 3 days, it has to be done. Product changes as per job order. The job or product is not predictable, any moment any kind of job may come, and you should possess few attachments which as and when required will be mounted in the appropriate machine tool and get the small work done. Occasional need of a process or product. So, it is not a regular process, and normally such kind of slow inaccurate activities are done under repair and maintenance work, where it is very much less manufactured. Dedicated machines are inexpensive and unavailable, where dedicated special purpose or single purpose machine tools are very expensive and because of that not available, then we can go for use of attachments in very conventional machine tools. Another thing, these computer numerical control machines which are very flexibly automatic, which has got wide versatility and flexibility and sophisticated machines, if they are available, then there is no question, there is no need of any attachment, and when we cannot afford it, we can go for attachment. We cannot afford it, we can afford it, we should not. Now, let us have some examples, say construction, principle and applications of various attachments in machine tools. Now, there are many types of attachments possible, but we shall discuss few common type which are being used for last few years and decades. Now, first is say this taper turning attachment which is used in as attachment in center lathe. Now, center lathe is a very common general purpose non-automatic machine tool, and this kind of machine tool is used for where attachments, special attachments are mounted to get specific work. Now, how is it done? Remember, taper turning in a lathe, taper turning is a very regular work which are normally done by offsetting the tailstock, by offsetting the tailstock, by swiveling the compound slide, by taking a form tool, or by combining longitudinal feed and cross feed. We can do that, but one attachment called taper turning attachment, if available and mounted, this will help lot in getting taper turning like this over wide range of length and angle. How does it work? You see, this cross slide is first delinked from this saddle. This is the saddle, it is delinked. So, this will move automatically of its own. Now, this is connected with a slide. This is called guide block. This is fitted, this will be slide along a bar. This is called guide bar. Now, when this saddle will be moving in this direction, this will follow this path. As a result, the cross slide will move inside along with longitudinal feed. So, now on this cross slide, there is the compound slide, on that there is a tool post, on the cutting tool is mounted. So, when this cross slide will be moving along this path, the cutting tool will also move along this path. This is how this taper turning attachment is used. Now, this is a graduation here and here. So, you can set this bar at any particular angle desired. Next is copy turning attachment used in central lathe. Copy turning attachment. Now, this can be mechanical type or it can be hydraulic type. Okay. Now, this shows the mechanical type. Okay. Now, what is there? This is the job to be produced. You see the product which has got a profile, a card profile ended with flat end and taper. Now, what you do? You have to produce first a template, a rod or a plate of this shape. Okay. This part will be replicated onto the product through the cutting tool. Now, this block, this is the attachment. Okay. This attachment is mounted on the saddle, but this template is fixed with the lathe bed at a point. So, when this block moves in this direction, this template does not move. This cross slide which is holding the tool moves in a transverse direction through this guide. Now, when this template, you see, when this saddle moves in this direction, then this stylus follows this path and is always in contact because this is a spring load. Because of the spring, this is always pushed in this direction. As a result, this stylus here is always in contact with this one, and so this will follow this path. So, this cross slide will follow this path, it will move in this direction as well as in this direction, resulting that along with the stylus the cutting tool will also follow this path, and then this will go right here, this will also right here, then this will go straight, this will also go straight. Like this, the entire thing will be copied, but it has got certain limitation. This is not very popular, this mechanical copying. The reason is the cutting force that comes onto the cutting tool is coming straight to the stylus at the contact point. As a result, there will be lot of vibration, wear and tear, and stick slip motion. So, the stylus and template will be damaged and quality of the product will be affected. So, it should be attempted such that this contact force will be independent and much less compared to the cutting force. This has been accomplished in hydraulic copying. Here you see the hydraulic copying. Now, here also this is the template which has got a profile like this. Suppose this is the profile which has to be produced here onto the job. Okay. Now, the cutting, there is a cylinder, this is a cylinder on which this is also a slide, cross slide, the cutting tool is fixed. This cross slide which has got two cylinders, one is the valve, other one is the cylinder, and this is the spool, which spool is the stylus here always in contact with the template under the action of the spring. Now, when this high pressure oil is coming through this and this enters, this tends to enter into this, and there are two ports here, not shown over here. There are two ports. So, this oil cannot enter into this chamber nor into this chamber, but when the stylus, because this whole saddle, this saddle is moving in this direction continuously, will be with the help of this lead screw. Okay. Now, when this will, so long this will remain on the flat surface, there will be no movement in the stylus and these two ports will not open, and the cutting tool will also follow a straight path. But when this will follow a curved path or step, then this port will open. When this port will open, the high pressure oil will reach here, all right, and pressure will be exerted on the cylinder, and the cylinder will be moving down against the piston which is fixed. Now, when this cylinder along with the cutting tool moves downward, along with the slight downward movement, say delta y of the tool, this cylinder also gradually moves downward delta y, and then first of all this port was opened. This port was opened here because of the movement of the stylus. Now, after the stylus moves, because of this pressure oil coming into this chamber, the cylinder will come down. As a result, the port that was the amount of port that was opened, now this will be closed. So, this movement, amount of movement of the tool, that is delta x, will be exactly equal to the amount of downward movement delta x of the or delta y of the stylus. So, this will be nullified immediately, but this is continuously drooping. So, again the port will open, again the cylinder will move down along with the cutting tool. So, this will move like this. So, this kind of movement will continue. So, this will move down, then horizontal, then vertical, like this, or this is y direction and this is x direction, but this roughness of the surface are very, very small. So, this will be almost linear on the naked eye. This is hydraulic, and the advantage is that the cutting force that is developed in the cutting tool will not be transferred to the stylus. Here the contact force is very, very small and independent of the cutting force. Now, another attachment frequently used in lathes, central lathes, what is called milling and grinding attachment. Milling operation in lathe, grinding operation in lathe, central lathe. Now, how is it accomplished? Now, if it is a milling, this shows a milling attachment. This is a grinding attachment. This is the lathe bed, all right. This is the saddle, this is the saddle. On the saddle, this bracket or this attachment, this is the attachment, this entire body is the attachment, okay, mounted on the saddle of the lathe bed. And then on this attachment, what are there? There is a motor for power, there is a gearbox inside, and then this is transmitted to the spindle. On the spindle, there is a milling cutter, all right, and this is the job. It is a cross section of the job, a rod which is supported in between the centers or chuck in a lathe perpendicular to this axis. And now, when this saddle will move along the bed, then this cutter will also move and produce a slot like this. So, this will produce a slot, suppose this is the rod and this will produce a slot here, okay, like this, a slot will be produced. Now, we can use different types of milling cutters, and by different type of milling cutters we can get different type of work. So, this can be a slitting cutter, a side cutter, a step cutter, or a now you can produce splines also. So, spline grooves. We can cut the tooth of gears if we use form tool. Okay. If we use a form tool or milling cutter, then we can machine this material in between the tooth of gear. So, lot of work can be done, milling work can be done in this process. Sometime this attachment is also provided with some attachment, further attachment, where a vertical spindle may be there, and you can put end mill type of cutter for cutting slots and similar work. Now, this is the milling attachment which can be used for many purposes. This is very versatile, very common. Grinding attachment. Now, mind that this cutter can be a form cutter. If you can, just like I told you that it can produce the gear teeth, it can produce thread also. Say in a lead screw, a thread has to be produced. These grooves have to be cut. Okay. So, this cut can be cut by this attachment, and this is called long thread milling. Now, grinding attachment, yes. Now, if you want to finish this thread, if you want to finish this slot, surface finish and accuracy, then instead of this milling cutter, we have to mount a grinding wheel, but in that case the spindle of the speed of the spindle has to be high, and a gearbox is not necessary. Here you can put a pulley, from pulley to pulley at high speed, and a spindle rotate at high speed, you can mount a grinding wheel. So, the grinding wheel can be used for finishing, accuracy and surface finish, for slots, splines, gear tooth, and then threads, screw threads, and so on. Various things can be done. And another advantage of this cylindrical the grinding, that the grinding attachment can also be used for cylindrical grinding, external cylindrical grinding and internal cylindrical grinding. Now, suppose there is a rod, this has to be finished, okay. This has to be finished, it is turned, and then you put a grinding wheel and there is a attachment which will be mounted on the saddle and saddle resting on the bed. So, the grinding wheel will finish it. Now, we can mount the internal grinding wheel to finish the bores. So, it is very useful device, very often used. Now, attachments used in center lathe continuing, meaning this is over. Now, next is spherical turning attachment. Now, spherical, not a complete sphere, but a part of a sphere, surface has to be produced. Say for example, here this is the job, okay. It has got a spherical surface. This is called external spherical or convex type spherical surface. How this will be done? The cutting tool is mounted on the tool post. Tool post is mounted on the cross slide directly, but the cross slide is driven by the cross feed screw manually or automatically, but the saddle is dealing from the screw. What will happen? This cross feed movement will be automatic, sorry, the cross feed will be given either automatically or manually, but the longitudinal feed of this saddle along with this whole thing, the cross slide etc., and the cutting tool will be automatic. Now, how this will be done? Here is a template. This template will be fitted into the tailstock, all right, and this tool post holding the tool on one side, there will be an extended rod holding a roller. So, when you pull this, move this cross slide towards the operator in this direction, then this roller will move in this direction, all right, and this cutting tool will also move in this direction. So, you get the entire surface. Now, if you want say concave surface, then what will you do? Then you have to use this kind of template. Other thing is more or less same, almost same. This will be mounted on the cross slide, the cross slide will be mounted into the saddle, saddle will be free or dealing from the lead screw or feed rod. So, the longitudinal feed can be automatic because of movement of the roller. That now, this is a system where this spherical turning is accomplished convex and concave by templates, conjugate templates, but this is a tedious job. So, every time you have to change it, and it is not easy, but this can be done without any template. This is another method. Suppose you want to produce this surface. Now, here is the saddle mounted on the lathe bed, and there is one bracket which is fixed, not fixed, mounted on this saddle by a pin. So, this block can be rotated about this pin and like this rotated with the help of this handle. Now, when you move this handle, this locus of the tip of the tool will be a curve, circular arc, and then because of the rotation, because the rotational job, this will be replicated this side also, and then you get the entire the spherical surface here. Now, if it is concave, then what has to be done? Then this R I, this radius R I, this distance can be changed. Now, remember this distance is very important. This distance means the radius of curvature of the sphere. So, by varying this length, we can get spherical surface of different radius. Now, come to internal concave surface, then the hinge point will be this side and this is the radial distance, and you rotate in this direction. So, that this will follow this path, curved path, and you get the entire internal spherical surface. Now, next now still we are continuing attachments used in center lathe. Now, we can observe that so many types of attachments can be used in center lathe. Center lathes are as such very versatile, so versatile that this is called father machine or mother machine, in which any type of work can be accomplished. At the top of that, by using so many types of attachments, you can get this processing capability further enhanced. Now, this is an example. What is this? Now, suppose this is a thread cutting operation. This is the job to be rotated at certain RPM, and then the lead screw has also to be rotated and with a particular transmission ratio, depending upon the number of teeth to be the pitch of the job to be cut and lead of the lead screw. So, according to this ratio has to be fixed by gears, and these two motions will be synchronized. So, when the job will rotate, the screw will rotate. When the screw will rotate, there is a nut. This is a nut. This nut is a part of the saddle. So, when this nut will move in this direction and the saddle will also move in this direction, and you get this tool movement. So, this linear movement, feed movement and the rotation together produce the desired thread of a definite pitch. Now, the problem is sometime because of some say error in the say transmission system or kinematic system, the actual pitch on the job we get say P A, which is different from what is expected. P S is the stipulated say 2 millimeter, but because of the errors inside the kinematic system, you are getting slightly less say 2.1 or slightly high or slightly less say 1.9 millimeter pitch. That is what is the error? So, it is plus minus 0.1 millimeter error. Now, what will you do? This difference, so this is the desired stipulated, this is actual and this is the error. Now, if this error be compensated by differential mechanism or servo system, then we can get very accurate thread in spite of having some error into the kinematic system of the machine tool. Okay. Now, how this will be accomplished? See, now this equation, you look into this equation, P S is a P. What is P A? P A is equal to job rotation 1 rotation multiplied by the transmission ratio U C multiplied by L lead of the screw. So, this is P A, all right. Now, what is delta P? Delta P is very interesting, maybe plus minus. This is when the saddle moves in this direction along with the entire system, that there is a this is the nut. This nut has got internal thread. This nut is basically a gear or pinion, and this pinion is against a rack, vertical rack, and the rack is in contact with a bar hinged at a fixed point on the lathe bed. Okay. Now, when this will travel in this direction, this will follow this path. As a result, this rack will come down. How much? Suppose when this one, the total travel is equal to say P S, the actual desired pitch, then this distance, then what is the amount of downward movement of the rack? This will be equal to tangent of alpha. What is alpha? This angle, inclination of the bar. Now, because of this movement, how much will be the rotation of this pinion? That will be, this will be divided by pi m z. What is the perimeter? So, this is the perimeter of the pinion. So, this will be the amount of rotation of the pinion because of linear movement of the rack this much. Because of this rotation of the pinion, this there will be some movement along the effectively on the lead screw. So, this will be multiplied by L. So, this is the total amount of movement of this nut because of rotation of the pinion by linear movement of the rack due to its movement along an inclined path. Now, what we have to do? We know P A, we know P S, all right. Now, we have to determine delta P correctly. So, P S is known, M module and Z number of teeth of the pinion is known, and only thing is according to Ps and Pa, find out delta P and put delta P into this equation and find out alpha. So, depending upon the error, amount of error, you fix this angle, alpha. Okay. Now, remember here I have shown that I told you that the correction, if there be any error, there will be a correction, but it can be used other way also. Suppose we want deliberately an unusual pitch, suppose P S is equal to 2, this is known, this is available in the standard and available in the machine, but we want 2.1 deliberately or 1.9, then what we shall do? Then also we can adjust this angle and utilize this attachment to get this, either this or that. This kind of requirement comes when we like to produce say differential screws. A screw will have a portion and then another portion like this with a larger pitch with a smaller pitch. Suppose this is 1.9 and here the pitch is 2. So, what is the effective pitch or lead? 0.1. So, if you rotate one complete, the large lead screw will move only by small amounts of 0.1 millimeter. Say for example, in EDM, ECM, this kind of differential lead screw are used, and for that purpose this kind of taper this attachment can be used for getting differential screw. Now, come to, so these are the things we described about the attachments used in drilling machines. Now, come to used in lathes, central lathes. Now, we shall discuss about the attachments used in drilling machine. Drilling machine. For example, there can be different type of work. In drilling machine, different type of work are done, already mentioned in the previous lessons, say boring, counter boring, counter sinking and all these operations. But here is one example of tapping attachment. What is tapping? Tapping means a tool which produces internal thread, say internal thread of nut like that. Now, this one, this is the attachment which has got a taper shank just like a drill shank. This will be fitted into the spindle of ordinary drilling machine, Okay. This one. Then there you see there is there is one clutch and another clutch. This clutch is spring loaded and this is guided by this key, but the lower clutch is free, it can freely rotate about the shaft, about this shaft. Now, when you want the downward cutting thread, this has to be moved down. So, this will rotate and move downward, resulting thread cutting, but the problem arises during return, because it stops and then returns by reverse rotation. So, this will rotate in the opposite direction. Now, this cannot come simultaneously, and if these movements are not synchronized, the threads will be spoiled. So, what is done after it reaches the end, say blind hole or blind thread, then there will be disengagement here because of some play or backlash into the clutches or clearance and spring loaded springs. These two will enable free return, safe and free return of the tap during reverse rotation of the spindle. Now, here is another example, little faster production. So, these are all say nuts, these are the all say blanks, nut blanks, say rectangular hexagonal shape with a drill hole, and these are magazine loaded and one by one is pushed. Now, this attachment is fitted into the drill spindle. Now, this will be rotating continuously. Now, this will be moved down. So, this tap will get inside this nut, okay, this blank, and this will complete this one. After that, when this will go up, this nut will go up along the tap and reach here, and then another blank will come, another thread will come. So, this will be accumulated, like all these nuts will be accumulated after thread cutting. But because all these things are rotating at high speed, because of the rotation at high speed and this chute is fixed, by centrifugal force these nuts will be thrown out and all of them will be collected into a bin. So, this is a little faster production of nuts by threading by an attachment. Now, shaping machine is a much more primitive, even more primitive than lathe, central lathe, and it is almost going to be obsolete, but even then at least earlier some attachments were used to enhance the processing capability of shaping machine. Some unstipulated work which are not supposed to be done in shaping machine could be done and by some attachments. One example, first example is the double cut attachment. You remember that in shaping machine this cutting tool cuts in the forward stroke, all right, and in the return stroke it does not cut. That is called idle stroke, which is a wastage of time and loss of productivity. So, if it can cut in the forward stroke as well as in the return stroke, then productivity will be doubled. Keeping this view, keeping this idea in mind, this attachment has been developed. Here you see that this is a rectangular piece which is hinged over here on a block. This block is rigidly fixed on the ram, which ram reciprocates in shaping machine. So, this is connected with the ram. Okay. So, this reciprocates. When it reciprocates and this moves forward, this cutting tool removes the material like this, and this one is arrested, you can see clearly, this one is arrested along this surface of this block. So, because the force is going there, cutting force, and this is the hinge, it cannot rotate further because it is arrested here. In the return stroke, when this will reach at the extreme end, then this one will move forward, this lever will move forward, this is spring loaded, and then this will go in this direction, and you see the orientation. Previously this surface was along this surface, now this here it will contact here, and this will be moving in this direction, force will act in this direction, but this will be arrested, hinged over here, arrested over here. Okay. So, this cannot move. So, it is cutting in the both the strokes. So, this way you can enhance the productivity. This was also attempted in planing machine, but not that required, not successful. Thread rolling attachment used in shaping machine. Now, this thread, screw threads can be produced in many methods, say even casting, rolling, then rolling, casting, forging, some in a very irregular type, and by non-conventional processes, various methods. In machining also there are different methods, single point chasing in a lathe, multi-point chasing, or you can use die, okay, solid die, spring die, and in different machine tools, automatic screw cutting lathe. There are many methods, but if you do not have such machines, if you have only shaping machine, but you want to produce some fasteners and the threads, then what you do? You can put this attachment, the center attachment on the shaping machine bed. Now, here is you remember that the thread rolling is a very common quick process of producing thread in fasteners. It can be circular die, flat die. So, this is a flat die. So, this is a one flat die is this. This is a one flat die which has got threads, and this is the blank, and this is another die. This is fixed which has got thread. Now, when it moves in this direction, so this thread is produced into that. So, this is a basic principle. So, this is a fixed die which is placed over here, and this is the moving die. This is the moving die which is made to move with the help of being connected to the ram of the shaping machine, and through this slot these screws or blanks or the screws are passed through, and they get into this slot here, and after this movement the thread is produced and goes away through this path. So, this was a very common process, but nowadays it is no more used to that extent, because thread rolling machines are available in plenty nowadays and very widely used as such. Another is attachment used in shaping machine. This is called Mattersome attachment. Truly speaking, this is a very old technique and being used very early, not nowadays, because gear teeth cutting, there are many processes, casting, forging, rolling, machining, grinding and what not. There are many methods. In machining, say form milling or forming, basically by milling and by generation process, by gear shaping, hobbing, then Sunderland method, rack type cutter and what not. This can be also produced by broaching very fast, but all these machines should be available. These are not very easy, not very less cost or low cost. Now, if required, this forming of the teeth of gear, suppose one gear has broken in a machine, only 2 teeth, and this is not available. So, what you have to do on this, so one tooth broken. So, what you do, you build the material, but deposit the material and then you finish it and remove this material and you get the tooth back. Now, this kind of work can be done in this kind of shaping machine with the help of an attachment. Now, this shaping, producing gear tooth in shaping can be done in 2 ways, forming and generation. The forming is neither accurate nor very reliable, but generation process is very reliable. This Mattersome attachment enables gear tooth cutting by generation method, maybe one pieces at one tooth gap at a time or one tooth at a time, and then it has to be indexed, the gear blank has to be indexed time to time, slow process, but this is very accurate, and this is not that accurate really, but much better than forming. How it is done? This is the gear blank, okay, mounted on the center. This is the bracket which is fixed on the table, mounted on the bed of the shaping machine, and this is the lead screw. So, this lead screw makes it move in this direction, that is called feed, or in this direction, whatever you call it. Now, the rotation of this gear blank and the lead screw are connected. That means, when this table will move in this direction accomplished by rotation of the screw, then there is a sprocket, this is a chain. So, this shaft will also rotate. So, along with the travel of this table, because of the rotation of the screw, this shaft, this will also rotate, and because of the bevel gears, this shaft will also rotate here. So, this gear blank, which was like this disc, it was here at the beginning somewhere. Now, this will be moving in this direction gradually. That means, the blank was here at certain height. Okay, this is the height of the tooth, and this is reciprocating perpendicular to the plane, just like a shaping machine, and this will gradually go in this direction. While going in this direction, this will rotate also. So, this rotation and translation, that will produce what is called rolling motion, essential for generation, and after it goes, this blank comes to this position, this cutting tool will keep on removing material and produce a tooth gap like this. This will produce a tooth gap like this. Then this has to come back again, bring it back, this will remain like that, and then this will be rotated, indexed. After indexing, you just produce another tooth gap. So, another tooth gap like this, you can produce the entire thing. Okay. Now, attachments used in planing machines. Now, friend, do not think that the examples that I am giving, these are the only possible attachments. There may be few more attachments also. I am giving some common type. Now, attachments used for planing machines, contour forming attachment. Now, suppose there are big bars or plates or tables or say beds or some machines, very large one, maybe 2-3 meter long or say 1 meter wide and thick. Here we have to produce some contour. This may be different type, say this is one type. So, this is one contour, or it can be concave type. So, this kind of contours can be produced in planing machine. How is it done? This is the workpiece, the cross section of the job. Okay. Now, here the job is reciprocating perpendicular to the plane. So, the tool is relatively reciprocating. So, it is cutting layer by layer. Now, this tool has to move along this path, along this profile desired. How it is accomplished? That first of all, this cross rail is dealing from these vertical screws. That means it can move up and down freely, and that is held in position, particular position by this screw as well as this bar, this bracket bar, hinge bar. Now, when you rotate this screw, this tool head along with the tool will move in this direction, but it cannot go straight because this bar will swing in this direction. So, this will also move in this direction. So, tool will also move in this direction. So, if you keep on rotating the screw, this tool path will also follow this path, that is this path or this path. This is how these are copied in planing machine. It is not exactly copying, but this is using a swing bar. Now, this radius of curvature, this is the radius of curvature, this length will decide, the radius of curvature. Okay. Now, another example, attachments used in planing machine, helical grooving attachment. Now, this is often we need some helical grooves of large pitch or large lead on cylindrical rods. Say, here is a rod, large rod of diameter say 200 millimeter, and the length is say 2 meter. So, we want to cut a groove, like this. How this will be done? First of all, this is a large job, so this cannot be done in shaping machine, and milling machine can be, but you do not have that kind of large milling machine, but you may have one planing machine. Then what will you do? You mount this rod in this fashion between two centers, and there is a bar which will clamp on this, and when this table moves longitudinally, this bar rests on another bar which is kept in an inclined fashion. Now, when this is, here is a bar inclined fashion, something moves in this direction, move gradually. So, this end will gradually fall, this will cause slight rotation of the rod. So, this rotation of the rod and the longitudinal motion will produce together this helical groove with the help of this cutting tool mounted over here, shown over here. Okay. Now, attachments used in some other attachments which are used in planing machines, shallow oil grooves of various patterns on the machine tool beds, hydraulic tracer control. Now, you know the hydraulic copying in lathe, where a template is used followed by a stylus replicated to the product. Similarly, in a planing machine also this hydraulic tracer attachment can be used to produce different contours by hydraulic copying. Milling and grinding attachments, this is a very common application. What is it? Here, suppose this is the structure, the cross section of a large a lathe bed or a machine bed. Now, this can be done in planing machines by single point tools, but single point tools are very low productive. So, then milling cutters can be used. Say one milling cutter will be used here, face milling cutter. There will be another face milling cutter here, and these face milling cutters will replace the single point tool. Single point tool does not require any motion, but the milling cutters requires rotation. So, these milling units, these milling heads will replace the single point tool head, and they will be mounted on the vertical columns of the milling machine or into the horizontal column. So, these milling heads will be hanging, or this will be put from side, and all these cutters will produce the job in one stroke. So, this is a very high productive system. Now, this is very common, utilizing this concept nowadays. A machine called planomiller has been developed. Now, if we want high finish or grind finishing after milling, then you have to replace the milling cutters, all the milling cutters, by grinding wheels, and all the grinding heads, but the grinding wheels will rotate high speed by individual motors, and you get all the surfaces, okay, done by grinding wheels. You can use grinding wheels. okay, and finish it. So, then this will lead to what is called plano grinder. So, plano grinders are very common nowadays, they are used and they are no longer called attachment. Now, this is the last stage, attachments used in milling machines, all right. You know, milling machines are very versatile, it is as versatile almost as central lathes, and lot of work can be done in milling machines. Now, amongst the conventional milling machines, which one is most common? That is horizontal R-bar type. In horizontal R-bar type milling machines, in the R-bar we mount different types of cutting tools, like say slab milling cutter, shell mill cutter, plain milling cutter, helical fluted or straight fluted, then side milling cutters, then double side cutters, form cutters, gear forming cutters, slitting cutters, slot cutters and what not. But all these cutters have got a hole, a bore, and through the bore this mandrel or the R-bar passes. This is the most common application of milling machine, but there are other kind of operations also which are accomplished by solid tools like end mill cutters with a shank, then face milling cutters. For that, different types of milling machines are available and normally used. Now, you may not have that amount of order or activities. Occasionally, this different type of work may come to you. You cannot afford purchase so many machines, milling machines of different type, but you may have, you purchase only one, say horizontal milling R-bar type, if you cannot afford, and then what you do, you just mount an attachment. This is an attachment which is mounted on the horizontal spindle, and this horizontal rotation of the spindle is converted into rotation of the spindle, vertical spindle. There you can mount this end mill cutter, even face mill cutter, and get the work done. So, this is one universal attachment. Next is another indexing or dividing head. Now, this, whether it is a doubt, you know, there is a controversy whether this should be called an attachment or accessory. It is so frequently and widely used in milling machine and also some in other machines, they are often called accessory. But since these are separately ordered and purchased and paid, we call it attachment, but it can be called accessory, there is no wrong, nothing wrong in it. What does it? What does it do? Now, this is rotation. A job has to be rotated, a rod or a job, rod like job has to be rotated. Now, not complete rotation, partial rotation, and then it is called uni-angle rotation. Every time you rotate by 1/6 or say 60 degree, then another 60 degree. This is called indexing motion. These are used for making prisms in milling machines, then cutting the teeth of gears. Okay, this indexing has to be made. Suppose you have to produce the gear. So, first of all you make one tooth, and by indexing then you cut the another tooth like that. So, this is called indexing, and for this purpose this attachment is used. For example, say there is a gear, okay. This is a gear to be cut which has got number of teeth, straight to spar gear. There is a milling cutter, it is a milling machine. So, this is mounted in a milling machine on the table, this is a bed or table, on the table this is mounted. Now, after mounting like this, this will be moved in this direction. So, you produce one slot or one tooth gap. After that you bring it back, after bringing it back you just index it. With the help of this mechanism you rotate this gear by one tooth gap. Suppose if it is 20 teeth, then 1/20th rotation this has to be rotated, and so by indexing you can do this kind of work. Now, this indexing mechanism can be simple type, elementary type, this can be compound type, this can be differential type. There are different types. Next one, rotary table. This is very common. It is a separate piece which is available in the market. It can also be considered as an accessory. Here you can mount the workpiece here. Suppose you mount the workpiece here, cylindrical or different type in a drilling machine or milling machine, mostly milling machine, and you can do different type of slotting, slitting, grooving like that, and this can be rotated about this axis with the help of this crank. Now, this can be done manually, or if you just join this screw or axis with the lead screw of the machine, then this can rotate automatically. So, this is a very common accessory, or is often called attachments and so on. Now, slotting attachment, can you believe that in milling machine the slots can be cut in terms, say, keyway slotting. Say there is a gear, so this is a gear blank and then a slot has to be cut, or if it is a spline then number of slot has to be cut. These internal slots can be cut by slotting process, and this is the slotting attachment which is mounted on the horizontal spindle. So, this rotation of the spindle is converted into reciprocation of the cutting tool. The cutting tool is inside and this is the workpiece. So, this will keep on reciprocating because of the rotation and you get this slot done, and then after indexing you can make another slot and the slot. So, you can do different type of internal work by the slotting attachment. This is was very common, but nowadays it is not getting that much used. Now, the major conclusions what we described so far, there are many other possible attachments for specific use beyond stipulation. All machine tools, conventional machine tools are stipulated for a range of activities, but that range can be expanded by some attachments for some specific work. New attachments, if needed, may be designed and built by people. Now, need and use, but all these things, so these are already getting used. Earlier it was more used, but it can also be developed further, but point is need and use of attachments are gradually decreasing. For advent of new dedicated machines, mass production. So, these machines are very single purpose and do a particular type of work at high speed and high quality. So, the attachments are no more necessary, and these machines are not expensive also, this can be procured. Machines are becoming more versatile. So, one machine can do lot of work, type of work nowadays. So, attachments are no more necessary, particularly after advent of flexible automation, for example, computer numerical control, milling machines and a turning machine and so on, machining center, flexible manufacturing system, which is highly flexibly automatic, computerized, any type of job of any configuration to any accuracy, any complexity can be produced. These machine tools are very expensive, sophisticated. It is not easy to make it available, but if available, they are coming to our reach, within our reach, and as a result, this will be the need and use attachments will be gradually eliminated. Thank you.